Parents are confused about what to do. We've also heard from many people who thought that the FDA, the government, was protecting them from these kinds of contaminants in food. And I think what the congressional report showed is that there's not the level of protection we need.
That was Jane Houlihan, research director at the advocacy group Healthy Babies, Bright Futures, which provides advice to parents on reducing children's exposure to certain toxic chemicals. Jane is talking about parents' reactions to a report released in early February by a U.S. congressional subcommittee. The report found concerning levels of toxic metals in several brands of baby food. And keep in mind, the fruits and vegetables that end up in pouches and jars in the baby food aisle are the same foods that the rest of us eat too. So this got us wondering, where do these metals in our food come from? And what can be done to reduce exposure to these contaminants? In this episode of Stereochemistry, we'll hear from agricultural scientists who are investigating how growing conditions may affect metal concentrations in veggies commonly used in baby food, such as carrots and sweet potatoes. And we'll hear about ongoing efforts by industry and regulators to bring down levels of toxic metals in foods, particularly food intended for children. I'm your host, Kerri Jansen. For this episode, I've asked C&EN reporter Britt Erickson to join us. Britt covers food and agriculture policy, as well as pesticide and chemical regulation. Thanks for joining us, Britt.
Hi, Kerri. Thanks for the opportunity.
So, Britt, you live on an actual farm in West Virginia, and your background is in environmental chemistry. So I feel like you're uniquely qualified to take us through this story.
That's right. So I grow a lot of fruits and vegetables. Right now, we've got some tomato seedlings in the kitchen ready to be planted.
So as someone who grows a lot of their own food, what was your reaction to this recent report on metals in baby food?
Well, I was surprised by the findings. When my children were young, I worried about things like bisphenol A in polycarbonate baby bottles and applesauce cups. Back then, we lived in an 1840s farmhouse, so lead paint was a really big concern. I never thought about metals in fruits and vegetables, though. I'm probably going to get my soil tested now, though.
Yeah, that's understandable. So what are the particular metal contaminants that we're talking about here in regards to baby food?
Well, in food, the metals of biggest concern are lead, mercury, and cadmium, all of which are neurotoxic. Arsenic is also a big concern in food, but as a chemist, I'd like to point out that it's actually not a metal, but rather what we call a metalloid. It behaves like a metal and a nonmetal, but many people incorrectly refer to arsenic as a metal.
Duly noted. So what are the health concerns related to exposure to these toxic elements?
Well, the primary concern is adverse effects on brain development in children. Arsenic, lead, and mercury can harm the developing brain, leading to impacts like IQ loss, attention deficit hyperactivity disorder, and behavioral and learning problems. Less is known about the neurotoxicity of cadmium. To get a better sense of this, I talked with pediatrician Phil Landrigan. Phil directs the Program for Global Public Health and the Common Good at Boston College, and he has a long history of witnessing firsthand the effects of lead in children.
One of the things we've learned about lead and mercury and arsenic and other metals is that every time we think we have established a safe level of exposure, we find to our chagrin that damage to health occurs in children at exposure levels below that limit. We see down to the lowest levels at which we can measure now that even low-dose lead exposure, especially if that exposure occurs early in life, causes lost intelligence and change in behavior in children.
In the 1970s, Phil was involved in studies of children living near lead smelters in El Paso, Texas, some of the first work to reveal the impacts of lead contamination.
The children appeared to be okay. When you looked at the children, they were happy, they were playing. But when we tested them, we had psychologists, for example, and neurologists test the children, we found very clear evidence that their function was diminished. Their IQ was reduced, their reflexes were slowed, their ability to focus on a task was diminished, their attention span was shortened.
These elements aren't safe for adults either. Lead, for example, is associated with cardiovascular disease. Chronic exposure to cadmium can lead to kidney problems later in life. Exposure to mercury is associated with neurological problems. And long-term exposure to arsenic can cause cancer and skin lesions. It's hard to avoid these elements completely. There are a lot of different potential sources in our environment. And so that's why scientists and others are doing what they can to solve this problem.
Right, and food, as we've heard, can be a significant route of exposure. So how are these toxic elements getting into the food supply?
Some of the problem is from legacy sources. So for decades, lead was used in gasoline and paint, and there's still widespread environmental contamination from those former uses. Lead arsenate pesticides were also commonly used in fruit orchards until the late 1950s. And various arsenic-based insecticides were once used on cotton, so a lot of soil contains lead and arsenic from those pesticide residues. And in some cases, metals are naturally occurring. Those metals are more difficult to keep out of food. Arsenic in particular can leach into water from natural sources, but human activities often contribute to the contamination.
Especially in areas where there's a lot of shale and where you find a lot of oil and gas extraction, you often find arsenic in the water.
That's Tom Neltner, the Chemicals Policy Director at the Environmental Defense Fund. He also told me, and I was surprised to hear this, that in addition to environmental sources, lead can show up in food packaging and in equipment used to prepare foods. We'll come back to that later in the episode. Tom represents the EDF as a member of the Baby Food Council. That partnership was formed in 2019 between several baby food companies and researchers at Cornell University and the EDF. Jane's group, Healthy Babies, Bright Futures, is also a member of the council. And several other groups provide technical advice, such as the U.S. Food and Drug Administration, or FDA, the U.S. Department of Agriculture, the New York State Department of Agriculture and Markets, and the American Academy of Pediatrics. The Baby Food Council's focus is developing voluntary best practices for both growing and processing food to minimize heavy metals in the products. Tom has been working to diminish children's exposures to lead for more than 2 decades. Until recently, he was focused on housing-related sources like lead paint and lead water pipes. He told me it wasn't until just a few years ago, when the U.S. Environmental Protection Agency began evaluating the role of lead in food, that he became aware that food could be a route of exposure too.
Well, I was aware of the arsenic in rice issue when it burst onto the scene in about 2013 as a result of some consumer groups doing some studies. But it was just focused on rice. So the one that really grabbed my attention was EPA's analysis in January of 2017 that showed for those children who live in a home that doesn't have lead pipes or lead paint, food was the biggest source, and the levels were significant. And that changed my view.
Tom notes that heavy metal levels in individual foods are low. But when you look at someone's overall diet and you add up all of the various sources, the cumulative risk is concerning.
What I found is that most parents don't realize that there are heavy metals in their food, much less the baby food that they often pay a premium cost to get. For them, it wasn't what they're used to. They've been told it's safe. So they're trying to wrestle with that.
I have to ask the obvious question here. We've talked about all the ways lead and other toxic elements can get into food. Once those elements are in a food, say a carrot, is there any way to get them back out again?
Not really. It's tricky because when you remove the metals, you also remove nutrients like beta-carotene. Then you would have to add those nutrients back in, and that can be problematic. Yes, in an ideal world, you would start with fruits and vegetables that don't contain heavy metals. But in reality, heavy metals are ubiquitous in the environment, and many crops take them up from contaminated soil. So that's why scientists like Tom are looking at other options to reduce the amount of toxic elements that end up on our plates, taking into account the complete journey a carrot goes through from the field to the processor to your kitchen at home.
What we're committed to is finding those best practices to drive down the level of arsenic, cadmium, and lead. And those best practices are something we've got to figure out. Some of them are common sense. Some of them we have a lot to learn.
So, Britt, let's start at the field where crops are grown. You talked with some agricultural scientists who are trying to reduce the amount of metals in crops that are commonly used for baby food. Can you tell us more about that work?
Sure. So one of the researchers I talked with is Lori Hoagland. She's a soil microbial ecologist at Purdue University. And Lori told me that the traditional ways of dealing with contaminated soil leave much to be desired.
So heavy metals are a challenge. So once they get into the soil, they don't go away. They don't decompose or degrade like organic contaminants. They're kind of stuck there. And so the ways we can deal with them are either digging the soil out and just taking it away. And in some really polluted environments, that's what is done. But that's really expensive and not always practical. So a second option is like phytoremediation, where you can grow plants that are very adapted to take up lots of heavy metals, like sunflowers and poplars, that kind of slowly take them up in their plant materials, and you harvest that biomass and then take them away. But that takes a long time to do. And so the third option is stabilizing those metals in the soil.
A big part of Lori's research is focused on that third option, which she sees as the most promising for growing less contaminated food. The idea is to stabilize metals in the soil to prevent them from being taken up by crops. She started with carrots. Root vegetables are especially susceptible to contamination from soil. Right now, Lori is trying to understand how metals bind to soil particles, and how variables like soil microbes, soil pH, and clay and organic matter in soil affect how much metal ends up in the crops.
We're trying to understand really a lot of those dynamics, how they work together, and even other pollutants too is another thing, like having microplastics in the soil, for example, can influence how strongly these particles bind to soil. And then we're also looking at other amendments and things that we can add to the soil, things that will encourage all those heavy metals to stick a lot harder into the soil.
In addition to her soil research, Lori is also working with plant breeders to identify varieties of carrots that take up less heavy metals. She also does a lot of work with quinoa, a grain that is increasing in popularity because it is rich in protein, fiber, and B vitamins. Much of the world's supply of quinoa is grown in Peru.
We know heavy metals, again, are a problem down there, and quinoa is a large crop, both for local people eating, but they're also exporting it around the world. So quinoa is becoming more popular worldwide. And there have been reports now that their shipments are being sent back because the heavy metals are too high in them. And so that's when we said, okay, well, are there ways we can identify genotypes that take up less? So to protect people and protect the farmers too, and help them to stay competitive.
While Lori experiments with carrots in Indiana, in Louisiana, agricultural scientist Arthur Villardon is investigating sweet potatoes. His research station in the northeastern part of the state takes advantage of the region's ideal climate for that crop.
It is hot and dusty, and that's part of the joy of the work here. But it's good weather for sweet potatoes. They like it hot, and, I don't know about dusty, but they like it hot.
Like Lori, Arthur is interested in the variables that could affect the uptake of metals by sweet potatoes. His theory is that growers can learn to control those sources of contamination once they're identified.
I think part of the goal of his research is to identify where those potential sources are. And the good thing is that growers, once provided with the proper tools to detect and identify these risk variables, they can easily manage this to some degree.
And what are some of the techniques that growers can use to manage heavy metal uptake?
Arthur says some of those best practices could be avoiding areas within a field that have a history of metal contamination and not using contaminated irrigation water. He also notes that soil pH, soil type, and history of flooding have been reported to affect metal concentrations in sweet potatoes. But the good news is that Arthur says he hasn't seen much of a problem of heavy metals in sweet potatoes grown at the LSU research station. So he's concluded that the team's recommended practices for fertilizer and pesticide use are not a major source of contamination.
We conducted baseline sampling in sweet potato varieties that we currently grow using recommended best practices, and the heavy metals are far lower than the FDA limits for bottled water. From time to time, I come across reports of heavy metals in sweet potato grown in high-risk areas, mostly near abandoned mines, But in general, these are reports outside of the United States. The key thing to remember is that this is consistent with what you know about heavy metals. They are natural elements of the Earth's crust and often end up in trace amounts in the food supply. It is the application of best agricultural practices by the grower that ensures that the vegetables, fruits, and grains are safe to eat.
Arthur's team has also found that there don't appear to be differences in metal uptake from one variety of sweet potato to the next.
We sampled 6 commercial cultivars, and we failed to detect any differences among those cultivars. So this is really good information to our industry, because that means that growers can continue to grow these cultivars and be able to ensure a good and safe supply.
Next, Arthur wants to probe whether certain parts of the sweet potato root take up more heavy metals than other parts.
And now that we have baseline data, we can now begin to answer the question of whether or not certain parts of the root preferentially take up heavy metals. Part of this research is to provide guidance to the industry, and such information will help to ensure consistent and uniform quality, not only for processing, but for fresh market as well.
Arthur told me he's not aware of any evidence to suggest that the sweet potato supply is currently causing any health risks. He is working with the industry as they conduct voluntary testing to document the safety of sweet potatoes, something he has a personal interest in addition to an academic one.
I make it a point to have in my lunchbox a sweet potato every day at the office. So I'm not joking. So yes, personally, I try to do it every day to support the industry.
Well, that's encouraging. I'm very fond of sweet potatoes as well. Quinoa, not so much. But I am glad to hear that scientists are working to make sure that these important crops are healthy and available. So we're going to take a quick break. When we come back, we'll take a look at the manufacturing side of food production and find out what industry and regulators are doing to help reduce metal contamination in food.
Hi folks, Arminda Downey-Mavromatis here. I'm an assistant editor at C&EN. We know you love stereochemistry, but did you know you can also get daily audio updates from C&EN? While you're waiting for the next podcast episode, you can catch up on chemistry news using your smart speaker. Chemistry Update is C&EN's daily news briefing for smart speakers. Every weekday, you'll get 3 short news stories, a mix of research breakthroughs, business deals, and policy updates. On weekends, you'll hear a roundup of the most interesting briefs from the previous week. Here's how you get it. On Amazon Echo devices, you can enable Chemistry Update from the app on your phone or by using a voice command. Just tell your device, "Enable Chemistry Update by C&EN."
I've added Chemistry Update to your flash briefing.
Then say, "Play my flash briefing."
Getting your flash briefing. From chemical and engineering news, here's your Chemistry Update.
It's that easy. Chemistry Update is also available on Google Home devices via Google Podcasts. You can find the full instructions for adding Chemistry Update to your smart speakers on C&EN's website, and we'll put a link to those instructions in this episode's show notes too. By the way, you can also listen to stereo chemistry from your smart speaker. Just tell your device, "Play the podcast Stereo Chemistry."
Getting stereo chemistry. Resuming episode 40.
And now, back to the show.
Okay, we're back. So, Britt, in the first part of this episode, we heard about the environmental sources of lead and other toxic elements that can get into our food. Earlier in the episode, you mentioned that scientists were also investigating potential sources on the processing and preparation side. So how do heavy metals come into play there?
Well, that's a question researchers, industry, government officials, and consumer groups involved in the Baby Food Council are trying to answer. I talked with Ruhai Liu, a Cornell University food scientist who is on the scientific board of the council, about that effort. Ruhai studies bioactive compounds in fruits, vegetables, and whole grains that prevent chronic disease. And he told me that scientists don't know yet what steps in processing may contribute to heavy metals in food. One possibility, he said, is that metals could be coming from the machinery. He also noted that they could come from cleaning the equipment and from other ingredients, such as salts, which are added during processing. Tom Neltner at the EDF mentioned that lead is added to brass and bronze, which are often used in coffee makers or equipment used to make hot water for tea or baby formula.
It's also commonly found in metal cans. We still see lead in the tin as a residual or maybe as an additive in the tin coating on the metal cans. From FDA's own data, about 97% of food cans for like pears, peaches, and pineapples had detectable levels of lead.
Those sources of lead are preventable, Tom says.
We can eliminate lead from tin that we use to make a metal can. We can eliminate lead from brass and bronze in food equipment.
Tom points to arsenic in rice as an example of how altering practices on the industry side can have a real impact.
Back in 2013, when we learned about arsenic in rice and how much children were exposed, the US Department of Agriculture, the industry, FDA responded by figuring out how could we reduce it? How could we buy from different sources? How could we prepare the rice so it was lower levels? Those practices have never really been explored with sweet potatoes, squash, and carrots. It's just not been on the radar of the processing facilities and the growers. So yes, it's a problem, but we think that we can make real progress on those kinds of foods.
Can we talk more about arsenic in rice for a minute? That was a really big deal several years ago, the first high-profile example of a toxic contaminant in baby food, in that case, infant rice cereal. What progress have we made since then to reduce arsenic levels in rice products?
Yeah, the good news is that levels of arsenic in infant rice cereal are lower than they were a decade ago. A lot of it had to do with pressure from advocacy groups and the threat of regulation by the FDA. In 2016, the FDA proposed a voluntary limit of 100 parts per billion in organic arsenic in infant rice cereal, but the agency stopped short of setting a mandatory limit. Last year, it finalized the voluntary guidance, but still declined to make it mandatory. But the FDA claims the voluntary guidance did make a difference. That's what I heard from Conrad Chouanier, Director of the Office of Analytics and Outreach at the FDA's Center for Food Safety and Applied Nutrition.
After we proposed that action level, industry took note and they started to take actions, whether it was adjusting the sources, where they were getting the rice from in order to make their products, and also looking at their whole production processes to make sure that they weren't introducing arsenic from other sources. Even given that it was voluntary, industry took note and took appropriate action in order to reduce the levels.
Conrad leads the FDA's Toxic Elements Working Group, which was established in 2017 to reduce exposures to toxic elements, particularly among children and other vulnerable populations. The group currently focuses on lead, arsenic, cadmium, and mercury, selected because they are both prevalent in the food supply and a source of exposure to children and vulnerable populations. Earlier this month, the FDA announced a multi-year plan to reduce levels of toxic elements in foods commonly consumed by infants and children. The goal is to get levels down to as close to zero as possible. Within 1 year, the agency plans to propose voluntary limits for lead in those foods and evaluate arsenic exposure. Later this year, the FDA is also planning to set a voluntary action level for arsenic in apple juice and issue draft action levels for lead in juices. What I heard from folks at advocacy groups is that although they are encouraged that the FDA is ramping up its efforts to reduce the levels of toxic metals in juices and baby food, they feel that the agency is moving too slowly. Here's Jane Houlihan of Healthy Babies, Bright Futures again.
They've finalized an action level for arsenic in infant rice cereal. That's a guidance level, not mandatory, and it took 10 years. And they've lowered the permissible level of lead exposure for children so that if they decide to take enforcement action against a product, they now have a stricter limit against which to compare. So they've done some things like that, but by tackling just one food at a time and, taking 10 years to finish a standard for arsenic in infant rice cereal, what we see is that it's going to take FDA 1,000 years to actually tackle this problem.
At the FDA, Conrad is aware of those concerns. He told me that from his perspective, the agency has good reason for moving at its current pace.
We need to give industry time to adapt their processes or their sources in order to bring these levels lower. Otherwise, if we move too quickly, too aggressively, although that's a laudable goal, we run the risk of having unintended effects, whether it's taking products off the market that have nutritional benefits, making products too expensive and therefore inaccessible to individuals, causing consumers to take actions that they think may be protective, but perhaps may not be, such as avoiding certain products altogether.
Nevertheless, Healthy Babies, Bright Futures, and other advocacy groups are encouraging the FDA to set limits for heavy metals in all foods consumed by children. Here's Jane again.
We'd like to see FDA set standards for heavy metals in all baby food and, really address the problem in a broad way, prioritizing the most problematic ingredients, but really addressing all the ingredients. If FDA took them on and set standards, it could make a big difference.
The EDF's Tom Neltner told me the Baby Food Council hopes to finalize its list of voluntary best practices in about a year. Those practices could include using a lab that has demonstrated proficiency at measuring heavy metals at low levels, setting limits for heavy metals in ingredients and final products, and purchasing ingredients produced according to agreed-upon standards. The details are still being worked out. The group hopes to release a draft this summer, seek public comments, and then finalize it in the spring. Here's how it would work. Manufacturers that adhere to the standard would be audited by a third party. If they pass the audit, they can use a special certification label on their packaging. Although the Baby Food Council doesn't have regulatory power like the FDA does, the goal is to make that certification desirable to companies because it could drive purchases.
And the purpose of that label is to allow parents to be able to identify the baby foods that are meeting more protective standards. I wouldn't expect to see that until late 2022. Well, that's not fast enough for me, and it's not fast enough for any of the companies, and I know it's not fast enough for my nieces and nephews with young children who want answers. It's a process that we have to take that involves public comment and really is driving the science. And we'll get there. So stay tuned for a label by the end of, I'm hoping by the end of 2022.
So while we're waiting on the Baby Food Council and scientists and regulators to sort this all out, some parents may be inclined to switch to making their own baby food. Does that help avoid the heavy metal issue?
No, actually. The FDA and advocacy groups agree that making your own baby food from produce won't solve the problem. That's because, as we heard earlier, oftentimes metals are already in the fruits and vegetables when they come out of the field. Here's the FDA's Conrad Chouanier again.
There's nothing wrong with making your own baby food, but we want to make people know that that doesn't necessarily reduce or take away the exposures. Lead and arsenic and those other toxic elements, they're present in our produce as well as in those jarred baby foods. As a parent, I know what it's like to be concerned about the foods that we're providing our children, although I do think that this issue can be scary, particularly for parents of young children. We don't want parents to be alarmed. They should know that the levels of these toxic elements are very low across the food supply. We find that children who have a varied diet that include a number of different foods have much healthier diets, as well as are able to better mitigate their exposures to toxic elements.
So what can parents do if they're concerned about their children's exposure to toxic elements in their food?
Well, Healthy Babies, Bright Futures and the American Academy of Pediatrics have a lot of resources available on their websites for parents. We'll include some links to those resources with this episode online. Some of their recommendations are very simple. Things like peeling and washing fruits and vegetables before eating them, particularly root crops like carrots and sweet potatoes that grow underground. Jane Houlihan notes that if parents are especially concerned about a specific product, such as rice cereal, they can consider alternatives like oatmeal and multigrain cereals.
So there are simple things parents can do, which is good news. But, in the bigger picture, because these heavy metals occur in almost every food we tested, and these small exposures can add up, we really do need government action and company action to reduce levels just across the food supply, especially in the foods with the highest levels.
So, Britt, a lot of the renewed interest in this problem stemmed from that recent congressional report. Has that report prompted a reaction from Congress? Do you expect to see any government action on this issue in the near future?
Well, it's always hard to predict what Congress will do. What I can say is that lawmakers in both the House of Representatives and the Senate have introduced legislation called the Baby Food Safety Act. The bill would require manufacturers to implement controls to reduce heavy metals in baby food. Food companies already have to do that for pathogens like salmonella. It's unclear, though, whether we'll see any movement on that legislation.
Well, thank you for bringing us this story.
Oh, you're welcome.
As always, you can find future coverage of this subject on C&EN's website. That's cen.acs.org. This episode was written by Britt Erickson and produced by me, Kerri Jansen. Story editing by Jillian Kemsley and Amanda Yarnell. The music in this episode was Organism, Floating Point, and Pebbles Dance, all by Roish Biegler. Stereochemistry is the official podcast of Chemical and Engineering News, which is published by the American Chemical Society.
Thanks for listening.